constant has always been too ambiguous. Let's take a look at this problem. Make a working copy of nullpointer.cpp, and I'm going to paste this into our working project. And this is the file here. Since the very beginning of the C language, the constant value 0 has served double duty as a null pointer constant. Ambiguity of meaning was dealt with by defining a preprocessor macro called null, which was typically defined as a zero-value void pointer. C++ did not adopt this behavior and does not support the loose typecasting of the void pointer like C does. This would be too ambiguous for C++ with its extensible type system. So if we look at what this does here, now here on line 5, 6, and 7, because of the transitional nature of C++ right now, because some C++ systems are already not defining the null pointer at all, I'm checking to see if it's defined, and if it's not, I'm going ahead and defining it the way that C++ normally defines it, which is as a bare 0. And then down here in our main, I'm calling this function and I'm passing it the null pointer, which of course in this case is a bare 0. But that null constant is usually used as a null pointer because the number 0 can often be used in that place, but not all the time because it also has a type, and its type is not a pointer and it's not castable to a pointer. So here we have two functions with exactly the same names. This is called an overloaded function, and it's distinguished by these different function signatures. One of them takes an integer and one of them takes a character pointer. So when I call it with this bare 0, you would expect it to just call the integer version, which is probably not what we meant in the first place. But in fact, at least in this version of C++, it gives us an error instead. And you notice our error message here. It says, call of overloaded f null is ambiguous, candidates are, and it gives us these two candidates. And if we look here at our little tooltip of the error, we see that. And here's our candidates with the little informational markers next to them. So this is not what we mean. And in fact, on your system, you may get an even different result. The point is it doesn't work, and there's no good reason why it should work. So if we do this with just a bare 0, you'll see that what we get, I'm just going to click the run in the background button there, is the int is 0 because we called it with a bare 0, and that's an integer. Now, if we call it with null pointer, and this is a new C++ 11 keyword, we'll just save that and run it. And again, I'm going to click that run the background button. You'll see we get this version, the pointer is. And that's because null pointer is defined in the spec as a null pointer constant that can be converted to a null pointer value or a null member pointer value. So it's actually a special constant of a special type, and it is a keyword in C++. The null pointer constant provides a much needed value to be used where the traditional null void pointer value has been used in C but doesn't work in C++. It resolves the ambiguity problems and can also be used in context of any pointer type. And now let's delete our working file and run clean to get set up for the next lesson.